Philip Wicksteed, a late 19th century economist who used math, engaged in an economic controversy with George Bernard Shaw. Shaw had distrusted math ever since as a schoolboy. A friend had said, let x equal a, and then proved by algebra that 2 equals 1. Wicksteed's reply is worth quoting at length. I quote, Mr. Shaw's youthful experiences about X and A are so highly instructive that I cannot refrain from dwelling upon them for a moment. His friend induced him to let X equal A, and Mr. Shaw, not expecting that X would take any mean advantage of the permission, granted the request. But he did not understand that in letting X equal A, he was also letting X minus A equal 0. And the proof of the proposition 2 equal 1 that followed with a rigorous exactness assumed that X minus A did not equal 0. Mr. Shaw arrived at the sapient conclusion that there was a screw loose somewhere, not in his own reasoning powers, but in the algebraic art, and thenceforth renounced the mathematical reasoning in favor of the literary method, which enables a clever man to follow equally fallacious arguments to equally absurd conclusions without seeing that they are absurd. That is the exact difference between the mathematical and literary treatment of the pure theory of political economy. End quote. Political philosophy became political science, in part through quantitative statistical methods. As Samuel Johnson said, to count is a modern practice. The ancient method was to guess. Statistics got its name from data collected by and about states. It's now a part of mathematics. Math has also made inroads on the language side of the liberal arts. Logic, long a part of philosophy because it concerns the general principles of reasoning, became mathematical logic. Nowadays, what is sure in logic is called mathematical logic. What is debated is called philosophical logic. Grammar in the hands of Chomsky and others became both a mathematical subject and a science, distinct in aim and method from philology, the natural history of languages. Rhetoric resists assimilation in the science, though math models of discourse and belief revision are currently sought. In the end, philosophy remains as the name for what we don't yet understand. When an inquiry is well launched, it leaves philosophy and becomes science, and nothing becomes science without its appropriate math. Before that, it is what the physicist Rutherford said of the whole career of the philosopher Samuel Alexander. Just words, words, words. What about the other section of the Cartesian lines? I've been talking about this. What about these? The horizontal sections are orthogonal to science, but perhaps useful for ordinary life. Our phenomenal world is magically filled with derivative productions of reality within the imagination, handy for living, but not for knowing. Secondary qualities such as colors are symbols in the human mind of primary qualities in real reality. The realm formerly known as the forms is likewise derivative, a social collective phantasm, such as a religious or political doctrine, a shared illusion, or perhaps better, a common convention. It's a seeming that we can mistake for a being. In the Cartesian picture, science is at right angles to common sense. So on the Cartesian picture, how much math is needed for wisdom? The answer was given by the physicist Weishaupt. When asked how much math the physicist needs to know, he said, more. Only the mathematician can be wise, because wisdom requires understanding, and only in and through math do we understand. Reality is mathematical all the way down. And in mathematics, we progress when confusion gives way to clarity that is simple. Lastly, we come to anti-Cartesian views. Just as the British and Americans are said to be divided by a common language, so the Cartesians and anti-Cartesians are divided by a common conceptualization. The anti-Cartesians rotate the Cartesian picture 90 degrees, so the mathematical physics line is horizontal, the imagination line vertical. The same structure, but a different valuation. The anti-Cartesian agrees, yes, science is orthogonal to human life, but so much the worse for science. What is telling about the divided line is not that it is a mathematical image, but that it is an image. Imagination endows being with meaning, and meaning is the center of human existence. Our world is not what Galileo said, a mathematical figure. It is a figure of speech. God is not a mathematician, but a poet who speaks a world into being. God could say what Yeats said of his poem, "I made it out of a mouthful of air." The lower part of the anti-Cartesian line represents the first act of our imagination, the production of our common sense world. The upper part of the line represents the higher act of the imagination, the work of creative artists. The mathematical sideline results from symbolic construction, and symbols are common sense objects to which we ascribe meaning. The entire scientific world picture is built with materials from our common sense life world. All scientific theories rely in the end on observations described in ordinary language. The world as depicted in mathematical science is not the reality that grounds our human life world. It is a derivative feature of that life world. The humanities, not the sciences, deal with what is really real. If you want to know what it means to be human, look to what is made by humans, that is, literature and history. Literature reveals more about human being than all of scientific psychology. When the mathematician brags that math is universal and necessary, the historian replies that math is merely virtual, whereas history is singular, contingent, and real. The mathematician, once a harmless idler, has become a positive danger. Lewis Carroll rightly named the four arithmetic operations as ambition, distraction, uglification, and derision. Math omits exactly what is important. Math considers more and less, but knows nothing of better and worse. G.H. Hardy, the purest among the purest of the pure mathematicians, was pleased that his work was remote from ordinary life and so kept it gentle and clean. Today, Hardy's love number theory is the basis of cryptology, used in e-commerce and warfare. And so Hardy's rhetorical flourish might apply to his own work. He said, "A science is said to be useful if its development tends to accentuate the existing inequalities in the distribution of wealth, or more directly promotes the destruction of human life." As for the charge that non-mathematical language is just words, the anti-Cartesian says that at its best it is, yes, just words, not in the sense of mere words, but of words that are just, fitting, exact, nuanced, and fully charged with meaning. As poet Igor Winter says, the poet understands the subject in rational terms and communicates simultaneously that understanding in the feeling which it properly motivates. A poem is a full and definitive account of the human experience. A poem is just words because it is what one should say. Unlike math's simpleton simplicity, arithmetic is a language with only one word. In poetry, confusion gives way to a clarity that is rich and complex. So, on the anti-Cartesian picture, how much math is needed for wisdom? Hardly any. The poet might need to count 10 to scan a pentameter line, but wisdom is non-mathematical in form and content. Math is not wholly without merit. As an art form whose material is ideas, math might be attractive to those so attracted. Certainly music as audible mathematics is delightful, but just as dancers can move beautifully without studying physics, so musicians can make music and audiences can hear it without knowing the mathematical underpinnings. One math course in college is plenty. So, where are we? The four answers to the question, how much math is needed for wisdom, have been drawn from different pictures of the divided line. I said at the start that I find each answer plausible and none completely satisfactory. I've tried to make each plausible. Now I'll try to say why I find none satisfactory. I begin with the Cartesian and anti-Cartesian pictures. They depict mathematical science and common sense as distinct and autonomous, and for the purposes of wisdom, embrace the one and exclude the other. Now here at last, I acknowledge that some of you are probably rightly annoyed with me for going on so long without terminological disambiguation. You want to say that the question how much math is needed for wisdom is ambiguous, doubly so, since, as I noted earlier, I defined neither math nor wisdom. And so perhaps both Cartesian and anti-Cartesian answers are correct, each on a different understanding of wisdom. Wisdom as scientific knowledge requires math, but wisdom as human prudence does